Okay, for lesson 2. So again, these first 2 lessons, like I kind of said in the first video, it's a lot of front-loading vocabulary so that we can work with it. So make sure we keep this all nice and neat and organized so that we can refer back to it later. So first thing we have here to talk about is we're talking in this lesson about angles and arcs, which you might not have learned about before. So to start with, we have what's called a central angle. This is an angle that starts at the center, i.e. central, of the circle. So look at the picture here. Here's the center. This angle comes from the center. So again, we would call that a central angle where the vertex, where it meets, right, starts at the center of the circle. Now, an arc is a new term. An arc is a portion of a circle. Now, we're going to talk about this in just a bit, but an arc is like this little piece right here. It's like if I snipped off the ends of the circle and I pulled it away, we're looking at just a little piece of the circle. Now, again, what we're really looking at is if like I laid this circle out with string or something harder, I guess I should say, and cut off the portion, I'm just looking at that piece of string. Yeah, that's what we call an arc. That matters later. Now, a measure of an arc is the same as its corresponding central angle. So we can say it as a number of degrees, right? Because if a whole circle is 360 degrees, we can measure arcs in degrees as well. So this is a chunk of 360 degrees. Again, the whole thing is 360. So whatever this angle is right here, it's going to be the same measure as this. So I say if this is 20 degrees here, we'd also say, well, this is also 20 degrees. So again, the measure of an arc is the same as its corresponding angle. Corresponding meaning the angle that creates it. Notice this angle creates this arc. That's what we mean by corresponding. However, there's actually 2 angles that are created by a central angle. We have what's called the minor arc, which is less than 180 degrees, and we have the major arc, which is greater than 180. So I could actually talk about this arc here, which is still created by this angle, or we could talk about the bigger arc on the opposite side. Technically still created by this angle, it's just the opposite side. So you can see that in the picture here again as well. Things to note, how we differentiate between these two, is that a minor arc, you'll want to write this down, is 2 letters. So I would, if I want to talk about this arc, I'm calling this arc AB. The minor arc, always 2 letters. A major arc, we need to name with 3 letters. So write that down. Minor arc, 2 letters. Major arc has to be 3. So notice this is called arc ACB, and this little symbol over the top, if you can't see it very well, it's kind of small. This is our symbol for arc. We just draw a little arc over the top. So we go from A to C to B. That's how we know which arc we're talking about. AB refers to the small arc. ACB refers to the big arc, minor arc and major arc. Now, we can actually also have one more type of arc, which is a semicircle. You should know what a semicircle is. It's half of a circle, but it's an arc whose central angle is the diameter. So this actually counts as a central angle here because it's a flat angle, but it goes through the center. So this actually counts as an arc because it's got a central angle coming from the center. It just happens to be a flat angle. And again, that takes up half the circle. So a semicircle, if a full circle, we should say this, if a full circle is 360 degrees, how many degrees are in half a circle, a semicircle? 180. You will want to write that down. A semicircle has 180 degrees since a whole circle has 360. So let's practice once again with identifying these things, same as we did in the last video. We've got just 4 here. Now there's a couple different ones in here, a lot actually. I am going to name 1 and then you guys can name another. So I'm going to name one central angle. So this is just any angle that starts at the center. So here's my center. I'm going to say angle KOL. Angle KOL. There are a lot of other angles. Go ahead and give another angle 3 points that starts at the center. What's another one? Well, I could have done KOJ. I'm not going to write all of them because there's a ton. I could do JOI, angle JOI. I could do angle IOH. Hopefully you're seeing a pattern here where the center letter of this angle is O. That's because this is an angle that comes from the center and the center point is O. So as long as you named an angle that has O as its middle letter, you're correct. Let's talk about minor arcs now. So remember, a minor arc is named by 2 letters and is less than half the circle. So when we name this, I need to pick something less than half the circle. So I'm going to pick, why not? I'm going to pick HI. We call this again arc HI. You need to pick another arc that you name by 2 letters that makes up less than half the circle. Go ahead and try. Okay, so another option you could have done is IJ. That's less than half the circle. I could actually do JL. Yes, I could do JK or KL, but I could say JL, and that is still a minor arc because it's less than half the circle. I would just only need to name J and L. We don't need to name K because a minor arc is only named by 2 letters. Other options again, HL, that's a minor arc as well. As long as when you follow it with your pencil, you're drawing less than half the circle. Okay, let's talk about a major arc. Now a major arc has to have 3 letters. And what we do is when I trace my major arc, the letters need to go in that order when I name them. So let's try starting at I. I could go I to H all the way around to K, and that would be considered I, H, K, a major arc because it makes up more than half the circle. I'm going to erase this. You're going to try it again as well. Pick any 3 letters in order that when you connect them, make up more than half the circle. Okay, well, here's an option. I could do, let's see, I could do L, K, H. Now, I could call this arc a bunch of different things, actually. We have options. I could call this arc LJH or LIH. We only use 3 letters. As long as I have the endpoints and then 1 letter in the middle, then you're fine. Let's see, can I give you one more? I could. I'll give you one more example you could have done. There's a ton, which is why I'm not going to list them all. But even KHL, that is KHL. That is a major arc. It's almost the whole circle, but it's not. When I trace it, it's almost the entire circle. There's lots of options. Again, the key with understanding what arcs they're talking about, because you're going to get confused a lot later, is follow them with your finger. KHL versus, noticed I used the same letter. I used the same letters here, but in a different order. That matters. Versus LKH. Those are talking about different arcs. The order of the letters for sure matters. Follow with your finger. Now a semicircle. So a semicircle is half of a circle exactly. There's a couple different ones we could name here. Now we also name a semicircle with 3 letters as well. So I'm going to say, I can see a diameter right here. So the semicircle is created by that diameter. So I'm going to call this one HJK. arc HJK. There's another diameter drawn in the circle, or I could call the other semicircle from this diameter. So go ahead, name one more semicircle, 3 letters, and it makes up exactly half the circle. So again, you could have used this diameter, just the other side. You could have named HLK or KLH, the same thing. HLK is another semicircle. Or, I'm going to erase all this. You could have named the semicircles created off of this diameter. This is another diameter, goes through the center. So you could have done like IHL, or you could have done LKI, something like that. We have lots of options. But again, I cannot stress enough, guys, because you're going to get confused later, how important it is the order of the letters. It's not just willy-nilly. The order of the letters you need to follow with your finger to understand we're talking about the right thing. So let's try this now. So we're going to identify a couple things here. We talked about up here, because we just practiced identifying, so we kind of may have forgotten, that the measure of an arc is the same as its central angle that creates it. So we're going to practice that here. So we are given only one angle measure, that this is 160 degrees. Now, excuse me, this is an arc measure. When we do these questions, notice some of them are angles and some of them are arcs. Very important to know the distinction. So we are given that this arc measure is 160 degrees, as well as that angle IOJ is a right angle. Notice the difference in the labeling. This is the arc versus the angle that we know. It's 90 degrees. Ooh, I meant to say that. You guys know a right angle. 90 degrees. Hopefully we do. We're going to use this information to find the following measurements. So you have to ask yourself, first off, is this an angle or an arc I'm trying to find? I already said it, but is this an angle or an arc? It's an angle. That's an angle symbol, right? So I'm going to look at my picture and I'm going to identify that. I'm going to find where that angle is. So this is angle HOL. So angle HOL, I want the measure of that angle. Now what we know again is that an angle and its arc, a central angle and its arc are the same. Notice that this angle creates this arc, right? The angle slices through the circle and it creates this arc here. So if this arc is 160 degrees, this angle is also 160 degrees. So we know right here at the center, that's going to be 160 degrees as well. Once again, this is only true for central angles. At the end of the video, we're going to learn a different type of angle, but central angles and their arcs are the same. So let's try the next one. Is this that we're trying to find in B an angle or an arc? That's an arc. That's an arc symbol. So we are looking at IJ. Let's identify it. Well, here's IJ. So I need to see what information I have. Well, I erased it. I didn't mean to. But we know that right here, this is 90 degrees. And notice that even though this is what we're trying to find, it is created by this angle. So if we know this angle, we know this arc. What does this arc have to be? 90 as well. That 90 degrees creates this arc, so it's going to be the same. Okay, so we got 90 degrees. Let me go ahead and leave that up there. There we go. Okay, letter C, once again, we want to drill this in. Am I trying to find the measure of an angle or an arc? This is an arc. That's an arc symbol. So I'm going to highlight that in my picture. HLK. H to L to K. So that's what I'm trying to find. Now this is a little bit confusing because I know what this is. All of this here is 160, but I don't know what this little piece is. So I need to have some other piece of information to help me figure this out. Well, if we notice this arc, its central angle is a diameter, right? This arc is created by this diameter. So this is what we would call a semicircle. It's half the circle, right? So how many degrees is going to have to be in this whole thing then if it's a semicircle? 180. A semicircle, half of a circle, has 180 degrees. So sometimes we have to use those pieces of information besides just what we're given. If we know that it's a semicircle, it's 180 degrees. Now, going on from here, we know that, again, this whole thing is 180. And what we are trying to find in this next question, hopefully we know by now that this is going to be an arc. We're trying to find this little piece right here, KL. Now let's think about what we know. We just figured out that this whole thing is 180. And we also know, and I can actually label that, why not? We also know that this piece of it is 160. How many degrees then are left over for KL? The whole thing is 180. This little piece is 160. How much is left over for KL? Well, that's 20 degrees, right? If the whole thing is 180 and I already know 160 of it, that means KL has to be 20. It has to be what's left over. So I'm going to go ahead and actually erase this 180 because now I know that this is 160 and this is 20. So I know that altogether this is going to end up being 180. KHJ. Okay, what I want you to do is I want you to try to find the next one, KHJ. So follow with your finger from K to H to J. Be very careful, KHJ. Let me see that real quick. Ooh, this one. Yeah, let me backtrack. Okay, so for this next one's a little tricky. There's lots of little pieces of information, and we're going to practice this together that we need to pull in order to do this. Now, the next one I'm trying to find is K. I'm going to follow with your finger. I want you to try it first. K to H to J. Follow it with your finger first, and then I'm going to draw it. Okay, K to H to J. You have to follow it in the same order. Otherwise, you're looking at the wrong angle. I need this whole thing. Now let's look at what we have. I know this piece is 20. I know this piece is 160. Well, I got a little gap right here. And then I know this is 90. So in order to get this whole thing, I'm going to add together all the degrees that I have, but we're missing this little piece. So here's what we need to notice about this. Notice that I have these two diameters crossing right here. They cross at the center. What that means is these two angles, if we can recall, what are these angles called when we have a cross that are right across from each other? Those are vertical angles. They're going to be the same. So if I have this little arc being 20, well, this angle is going to be 20, and then this angle is going to be 20, which leads us to this little missing piece right here is also going to be 20. So we even have some old stuff coming in for us. That's vertical angles. If we have two diameters crossing, those arcs that they create are going to end up being the same. So now what I want you to do is I want you to find the whole blue angle. We know this is 20, 160, another 20, and then a 90. Get all of that together. What do we get? Okay, so we're going to just add it. We got 20 plus 160 plus 20 plus 90. You should get 290 degrees for the whole thing all the way around in blue. Now we have one last thing we're trying to find here. Let's see, let's do purple, why not? We want the measure of JK. Now, I know this whole thing is 290, and I want to find this arc. Notice that this whole thing being 290, and what I want to find is this is just the rest of the circle, right? We have all of 290. What I want to find is the rest of the circle. So I want you to think for a bit. We know how many degrees are in a full circle. So think about how much JK should be and try it. Well, again, this whole thing is 290, but a full circle has 360 degrees. So to find just that little missing piece, we can take away 290, which I believe is 70 degrees. Let me double check. Yep, and that is going to be the measure of that arc. 290 plus the 70 is going to give us the whole circle. So again, we're going to practice this more in class before I have you guys do the assignment. I know it's confusing. It's a lot to keep straight. We'll try it again. Before that, however, I do want you to guys to, excuse me, copy down these last vocabulary for this lesson at least. There's probably more later to have, because this stuff is a bit harder and we're going to go over it in class, but I want you to have it copied down to start with. So last bits of vocab here. We have a new type of angle now. We have to keep these straight. An inscribed angle is how we say that. It's an angle inside a circle, inscribed, right? That starts and ends on the circle. Notice the difference between a central angle that starts in the center versus an inscribed angle that starts on the circle. So be very careful. This is an inscribed angle, not a central angle. Starts and ends on the circle. Now with these inscribed angles, we have what's called an intercepted arc. And this is just the arc that the angle opens up to. So this angle opens up to this arc, right? Here's my angle. Kind of makes a little pizza slice, right? It opens up to this arc. So we would call this the intercepted arc, arc AC. Now you're just going to write this down for right now, and like I said in class, we're going to practice it. What we know about this is there's actually a relationship between the inscribed angle and its arc. It's that the angle is half the measure of the arc. So once more, we need to keep this really straight. When it's a central angle, these two are equal. When it's a central angle, these two are equal. When it's an inscribed angle coming all the way over, the angle is half of the arc. Think about as it pulls back, if you almost think about it like a slingshot, as we pull that slingshot back away, if like I had my slingshot right here and then I pull it back, I'm getting tighter and tighter and tighter on that angle. So again, the angle is half of the arc. We're going to work on that in class a bit more though.